Let's start now by looking at some definitions. This is the vocabulary we'll be using to deal with the material in this unit and in the next unit when we're dealing with another type of interest. The first word or one of the first terms we'll be seeing is what is a principal, other than the head of a high school, but we use a different term here. We're going to use the word principal to mean the amount that you've borrowed that you will be making payments on, or the amount you've invested. In other words, you've given someone the use of your money and they will be paying you for the use of your money. Now, the interest is what we're really going to be dealing with here, because the interest is often expressed as a percent of the principal, and that's the fee that a lender charges to a borrower for the use of the money. So, for example, if I lent you a few $100s, then if we were friends, you would just pay me the money back. But if we were slightly less than friends, I would say, okay, in addition to paying me the money back, I want you to give me a little extra money because it was money that I didn't have to use while you had it. So the money you pay me for the use of my money is called the interest, and often you decide on that by some percent of the amount I lent you. So, for example, I would expect more from you if I lent you $10,000 than if I lent you $1,000. Then we can talk about something called the annual percentage rate, which when you read financial documents, you'll see often referred to as APR. If I lend you something for a year, what is the rate? What percent do I charge you over that year to use the money? The annual percentage rate, and of course annual means yearly. Now, simple interest is interest that's calculated only on the original principal. And what that means is that if we think about what else the interest could be calculated on, you can get more complicated, because you can also calculate interest based on interest that may have accumulated in the past, so that what will happen is if you have the interest calculated on remaining interest, if you have a savings account, that means that you get even more money back, because, for example, if you have $1,000 and earn $100 interest, then the next piece when they do the calculation is based on $1,100 rather than the original $1,000. So that's really good. Calculating the interest on everything is really good because it's great for a savings account. But if you have a mortgage or credit cards or something like that, it means you're paying more than just APR, the annual percentage rate, on the principal only. That's called compound interest. And it's the interest that's calculated on the principal, which is a percentage of the principal, and any previously earned interest. So compound interest, which we'll be dealing with in Unit C, is interest that's earned on the principal and the previous interest put together. Let's look in this unit, though, only on simple interest. Here's the definition. The simple interest, what you pay, is based on the principal, how much you start with, what you've given, times the annual percent rate. In other words, that's the APR, how much you pay per year in terms of a percentage, times the number of years. We write that as the interest is equal to P the principal times R the rate times T the time. Let's look at a simple example. For example, if I have $5,000 that I've lent someone, and they're paying me back at 5% of that $5,000 per year, and they're going to pay me at the end of 2 years, I can ask, how much in addition to the $5,000 am I going to get for the use of their money? I need to change the 5% APR to a decimal in order to do the math. 5% is equivalent to 0.05. When I work this out, I find that at the end of the 2-year period, in addition to getting the $5,000 back from the person or agency that I lent the money to, I'm going to get an additional $500. You can see APRs all over the place. This is a document that I found on the internet and copied, and in the circle are different APRs. In other words, one credit card charges you 9.99% to use their money. Another credit card looks like it's charging you 12.24% APR to use their money, and so on. So of course, when you go shopping for a credit card, you want to try to find one with the smallest possible APR, the smallest possible charge to you for the use of the credit card company's money. I just wanted to point this out to you to show you this screen so that you see that the idea of APR is a very common one that you're going to find used in a lot of different places, and it's good to know what it is. Here is a blow-up of one of the screens that we'll use as an example. If your credit card has a balance of $12,500, how much yearly interest would you pay at 13.99% APR, annual percentage rate? Okay, let's look at what we're given. We're given the $12,500 balance, just about 14% APR, and we would like to know what the yearly interest is. Here's what we're given, and here's what's asked. And to put in some kind of a small diagram, that whole circle would be the whole $12,500, and that chunk might represent the approximately 14% that you're going to have to pay the credit card company in addition to the $12,500. Using the formula that the interest you pay is the principal times the rate times the time, I now substitute in the numerical quantities for that. Remember, it's the amount you start with times the percent rate per year times the number of years. When I work this out, of course, I have to change the 13.99% to a decimal. And I find that rounded off to the nearest penny, what you would owe the credit card company in addition to the $12,500 is another $1,748.75. And of course, can I check this? We ask the question, does $1,748.75 actually equal 13.99% of $12,500? We set this up as a percent and do the division as indicated and find out, yes, working the problem backwards, taking what we've gotten and then working back to calculate the percent gives us, within round-off error, exactly the same percent, so we can say that we've done this problem correctly. Let's look at another example that works in the same way. Sylvia takes out an $8,000 loan at 8.5% APR. That's for 1 year, but she pays it off in 3 months. And now we're going to ask, how much interest does she pay? Looking for the information, $8,000 loan, 8.5% interest rate per year. How much interest does she pay? Here's the information we're given. That's what's asked. So we need to take the principal and look at the interest for 3 months where we are told what it is for a year. Let's start here. The interest is the principal times the rate times the time. That's the amount of the loan. There's the APR. And now it's not a year, it's 3 months. Making this into an equation, the interest is 8,000 times the percent times 3 months. We're dealing with years because the APR, the first word in APR is annual. We need to express 3 months as a year. I do it this way. 8,000, the principal, expressing the interest rate as a decimal, and then I need to express months as a year. 3 months is 3/12 of a year, so I can use that fraction there. 3/12 is equivalent to 1/4. On the next slide, we'll continue with the calculation. This is what we have so far. If I multiply the first 2 terms together, I get $680. That's what I would owe in interest at the end of a year. But since I've only kept the money for 1/4 of a year, I don't owe all of that interest. I multiply by 1/4, or equivalently divide by 4, or equivalently multiply by 0.25, however you care to do it. When you actually work that out, you find that the interest is $170. After 3 months, Sylvia owes $170 in interest. To check this, we have that the interest is at $170, and we can do a reasonable thing. 8.5% is more or less, and take that funny symbol to be a more or less, 10%. 10% of $8,000 is $800. And then if I figure what is 1/4 of 800, it's about 200. 200 is, kind of in the neighborhood, in the ballpark of 170. Let me say that because my estimation is close enough to 170, I'm going to say that I've done this okay. And those funny little symbols are not exactly math symbols. They're just something that I threw in there to mean more or less, because I'm doing some estimating here. We've talked up to this point only about the interest itself. We're going to now look at something called the final balance, and that's defined as what you actually have if someone is paying you, like if a bank is paying you, at the end of whatever the period is, or what you owe. In other words, it's the principal plus the interest added to it. We express it this way: B, the final balance, is equal to P plus I, principal plus interest. And if I write out what the interest is, remember the interest is the principal times the rate times the time, I notice something. When I look at this, I have the principal times 1, P, in that first term on the left. Then in the right-hand term, on the other side of that plus sign, I have PRT. I have P in both of those expressions. Why don't I factor it? I have P there. I can do this using the distributive rule, that the final balance is P, the principal, times the quantity 1 plus the rate times the time. What I have here is effectively 2 absolutely equivalent expressions for the final balance, and there are different places where either of them may be more useful. You can turn one into the other in the very simple derivation I did, or you can remember them. I prefer to remember as little as possible myself, so that I would usually just substitute PRT for I and then do it myself. Remember what you like. This is an important quantity. Let's look at how we would use it, but with an example. Maria deposits $750 in an account that pays 6% yearly interest. If the interest is simple, in other words, you don't pay interest on the interest, how much does she have in her account after 6 months? Looking for the information, there is the basic information that we've abstracted from this problem, and of course we'll summarize it. This is what we're given. This is what we want to know. How much, what is the final balance in her account at the end of a 6-month period? Here's what we're looking at. There's the initial deposit. Then the final balance is that initial deposit with the 6 months interest added to it. Here's the information that I have. Those are the formulas written every which way for the final balance, and there's the information given in the problem. Let's calculate the interest and then add that to the principal. The interest is principal times rate times time. I'll put it in this way, change rate to a decimal, and 6 months. Remember, we're talking yearly. 6 months is 6/12 of a year, or 1/2 of a year. Let's continue to work on this. When I do the calculation, I find that in half a year, the principal of $750 will earn me $22.50. Then I can add that to the principal to get the final balance. When I do that, I use $750 for the principal, $22.50 for the interest, add them together, and I find that my final balance is $772.50. Notice that I have method 1 at the top of that slide. That's because I'm using the formula that the final balance is equal to the principal plus the interest. Let's use this other formula, that the final balance is the principal times 1 plus RT, the rate times the time the loan has gone out. Again, there is the information. When I do that, I substitute into that equation. It's $750 times the quantity 1 plus 0.06 times 1/2, or $750 the principal times 1 plus 0.03, 0.06 times 1/2 is 0.03, $750 times the quantity 1.03 when I add those two numbers in the brackets together, and I get exactly the same result, $772.50 at the end of that half year. Now let's turn this process around a little bit and look for a principal we might have, the initial amount of money we want to deposit based on information, how much money we finally have as a final balance, the percentage interest rate and the time and so forth. Let's use a problem to see how that works. Rosie wants $12,000 for a motorcycle, but she doesn't have it, so she'll deposit a lesser amount of money to get the $12,000. How much does she need to deposit at 6% APR at simple interest to have the $12,000 in a year and a half? Now that's planning ahead if you ask me. Here's the information. She wants $12,000. That's the final balance. How much does she need to deposit at 6% interest for a year and a half? Let's summarize the information. We're given the final balance is $12,000. The rate of interest is 6%. for 1.5 years, and we like to know how much she needs to deposit now. Let's look at it this way. How much does she deposit now in order to get $12,000 given the 6% interest in a year and a half? So our total final result is that $12,000. The final balance is the $12,000. We can use this formula and then try to put in what we know. The final balance is $12,000. That's equal to the principal, which we don't know, times the quantity, 1 plus the rate, 6%, which is 0.06, times the time, which is a year and a half. We now have to work with what's inside the brackets and do the multiplication. The first thing I'm going to do, as this indicates, is multiply the 0.06 times 1.5 and then add that to 1. 0.06 times 1.5, this is almost like adding 15% for a waiter. 6 added to half a 6, which is 3. 6 plus 3 is 9. There's the 0.09. Add that to the 1. I could more or less do this one in my head if I remember that little trick. So I have the equation which has an unknown p in it. $12,000 is equal to p times the quantity 1.09. How can I get p by itself? I divide both sides of that equation by the quantity 1.09, and then when I do that, I find that p by itself is very close to equal to $11,009. This would tell me that in order to have $12,000 in a year and a half, if Rosie puts in $11,000 now and then lets her money grow, she will have enough to realize her dream of a motorcycle when the interest rolls around to give her the final balance of $12,000. Now, let's change perspective again, and suppose we're looking for a missing interest rate given the rest of the information. Let's use Rosie again as an example and turn this problem around. We ask, what simple interest rate, if she had $11,000, that would get her to the $12,000 in 8 months? Boy, that's going to be quite a bit of interest because she needs to get it pretty fast. She wants her $12,000 only in 8 months. The bank may not pay that. We'll have to see. But what they're asking for is, what's the APR? What information are we given? She has $11,000 as the principal. The final balance is $12,000. The time period is 8 months. And we would like to work the other way to calculate what the APR is. We're given $12,000, $11,000 now, $12,000 in 8 months. And we're asked, what is the yearly interest? Here is a diagram. Here's how much we have now. There's how much we have in 8 months. What is that interest? Let's see how we would do it. Again, we could use this formula that the balance, the final balance, is equal to the principal times the quantity, 1 plus the rate times the time. Plugging numbers into that, I get 12,000 final balance is equal to 11,000 times the quantity, 1 plus R, the rate. That's what we're looking for, the interest rate, times 8 months. 8 months is 8/12 of a year, and since the interest rate is expressed in years, our time also needs to be expressed in years. We write this out now, we expand this. We need to solve for the unknown R. $12,000 is equal to $11,000 plus $11,000 times R times 0.67, which is basically 2/3 of a year. We do the mathematics, so we get the equation now. 12,000 is equal to 11,000 plus 7,370 R. We need to solve this for R, the interest rate. I first subtract $11,000 from both sides of that equation to get that 1,000 is equal to 7,370 R. Now I divide both sides of that equation by 7,370, and I find when I work this out that R is equal to 0.14. Now when I change that to a percent, I find that Rosie needs to find some kind of an investment that will pay her 14% interest on her loan.